Excellent job. So we're going to go over the answers here. These are the same vocab words we have had every single day. Dwayne, head up, so it shouldn't be an issue. The amount of matter in an object, John Kira, mass is correct. Number 2, a material that easily allows electric and thermal energy to pass through, Jalen. Conductor, very good. We've been learning in our circuits that conductors are the what of the circuit? That sounds really silly, okay? Conductors are the what? The wire, very good. Draw an arrow and write wire. And these wires are typically made of what material? These wires are typically made of what material? Copper/metal. Make your paper not rubber. Rubber would be an insulator. Yeah, don't do that. The variable that is measured in an experiment, what did you say, Malik? Dependent variable, very good. Number 4, a measure of the strength of a force, Jose? Magnitude, awesome. Number 5, a question that can be tested through a scientific experiment. Oh, testable question, very good. And number 6, the universal force of attraction between all objects, Ramaya? Gravity. 7, a measure of how much gravity an object experiences, Jalen? Weight. 8, the length between two objects. Go ahead, please, Destin. Distance is correct. I'm sorry, what was that, Destin? Oh. Stored energy just when an object's position. Go ahead, Ashira. Potential energy, very good. Now it says which drawing below so the light bulb connected in a parallel circuit, A or B. First, give me a college hand. Is it A or B? If you don't know the answer, what should we hold up? A fist. Thank you very much, Devin. So Nana, Angel, I need that participation. Very lunchtime? Oh, no problem. Thank you. Tracking, John Kira. Very good. She says B. Thumbs up or thumbs down? Look, clappy clap. Very good. This is our parallel circuit. Please label it in the image as parallel, which means we're labeling circuit A as what? Series. Very good. Now, we're going to focus only on our parallel circuit and label all of the components. The battery should be called the what? Very good. This line going around is the what? Conductor/wire. Very good. Now, focus up here. What is this opening? What would we call that? Sort of like a light. Very good. It is the switch of the circuit. Okay? We're getting there. These 3 circles are the light bulb, which also represent the what? Resistor. Thank you. Now, yes, Dustin. What's the what? Dustin, you know what a light switch is? Like when you go home and you flip the switch? Okay, don't say anything stupid again. Here we go. What is an advantage of using a parallel circuit to make a string of decorative party lights? And we saw what happened with our lights. All attention is going towards her. Tracking, Jalen. There's something very wrong with her response, and it is worth $1 million if you find it. Jose. Incorrect. Jalen said the advantage of using a parallel circuit is when the circuit is open, all of the lights will work. What is the error in her response, Ramaya? The electrons, or electricity, very good. So right now, class, this is an open circuit. The fact that the switch is open means that it is incomplete. The electric current will come here like, and it can't jump across. What do we need to do with this circuit to make these light bulbs light? We have to close it. A closed circuit is a complete circuit, and the current it keeps flowing. Amen. Hallelujah. A closed circuit is a complete circuit, and the current can flow through and light the bulb. Okay, let's try. A closed circuit is a complete circuit and allows the current to flow through and light the bulb. Let's try one more time. Let's say we say something. A closed circuit is a complete circuit, and the can keep flowing like the light bulb. It's beautiful. I love you. It's wonderful. So now let's go back to the original question. What is the advantage of the parallel circuit? Oh, so everybody else gonna be in lunch intervention. I'll take it. Oh, you gonna roll your eyes? It's okay. Sit down. So again, if you can't participate, we'll talk about it during your lunchtime, and that's quite all right. Thank you for your fist, Dustin. It lets me know you're with me. You may just be a little confused. What is the advantage of the parallel circuit? Tracking Jose. Yes, that's what I'm looking for. One advantage of the parallel circuit is if one resistor, awesome, Marmar, goes out, all other resistors will continue. Not only are you going to receive a demerit, it's going to be a lunch break. So you got to stop tapping the pencil. If you're frustrated, put your hands in your lap. Will continue to light. Because remember, in a parallel circuit, what happens to one does not affect the rest. All right, ladies and gentlemen, great job here. You are going to turn the page. One more page to review. You have 4 minutes. Go. To produce light, I want to do a clap show. Ooh, yes, all of my folks, they show me they ready already. Here we go. And KIPP. Oh, wonderful, wonderful. The correct answer is A. Very good. Now, if you are a shoot caller, baller, shot caller, which you are, please right now go ahead and draw your arrows to show the flow of electricity. Excellent. Love that urgency, Lamira. John Kear's looking at me like, what are you talking about? It's okay. I need at least 4 arrows in your illustration. And track back up here. If this is the left side of my battery and this is the right side, which way will the electricity flow? Go ahead, Ramaya. From the negative to the positive. So your arrows should go in this fashion. Very good. Let's go over here. What will occur when bulb B is unscrewed? So we're taking a look at this. I'm going to circle bulb B because I know that this is the bulb we're talking about. And give me, show me, you ready? Here we go. And KIPP. I see 1, and then Malik's going like this. The correct answer is A. Very good. Now, someone tell me why. Why will all of the bulbs go out? Tracking Marmar. He says because all of them are unscrewed. Someone address that response. Tracking Imani. Imani, beautiful response. We're going to jot that down so that this knowledge sticks. So I want you to write all bulbs. Oh, thank you. Will go out. So needed. Thank you, Hack. Because this is a series circuit. And what is the hot Cheetos in there? Oh, and the flow of electricity must remain closed. If we unscrew one of these bulbs, it's like creating an open circuit or flipping open a switch. Electricity can't flow all the way around, and we saw that with our lights. Now, big man idea at the bottom, what is the difference between a series and parallel circuit tracking? Dust Bunny, thank you for that fist. Dust Bunny. It's beautiful. Build on it, Ramaya. Go ahead. Ramaya. Very good. So I'm going to merge what you guys kind of said together. In a series circuit, electricity flows across one branch and basically in a straight circle. Electricity flows through one branch, and each resistor is dependent upon the other. Remember, they're like twins, right? So if Jaylin and Malik are twins connected, then when I slap Jaylin, Malik will say, ah, okay? It's like they're connected. You see what I'm saying? Branch and each resistor is dependent on the other. But in a parallel circuit, each resistor acts independently because it's on a different, there we go. We working with the trees. Here we go. In a parallel circuit, oh, you got all this, huh? Each resistor works independently on its own branch. I'm so sorry. Yes, I'll give it to you once I'm done. Now, we're kind of done talking about the basics of circuits, and we have to merge in some information about electromagnets, or magnets that are powered by electricity. We're going to see a quick video after we read our text that shows you the power that we can get when we merge electricity and magnets. We're on advanced groups next week, and the circuits are actually supposed to be delivered tomorrow, so I'm going to spend the weekend setting up our lab test for you to build your circuits on Monday. My advanced groups are also going to the next level and actually create the electromagnet. So that would be my folks that are able to complete their circuits the fastest and have the strongest understanding. Yes, ma'am. So there's actually some groups who are going to work by themselves because we ordered different circuits. So for those people who would like a lab partner, I will give you a lab partner. If you want to build your own circuit on your own, then you will be able to do that. Is that fair? Awesome. Thank you, Lina. All right, let's go ahead and turn the page and take a look at our text for today. What is magnetism? So I'm going to talk about magnetism first and then bring in the information about electromagnets. Now, when I pause, you can let go. Remember when we first discovered that two magnets could snap together and stick like glue? Remember the force when you held two magnets close and something either pull toward one another or repel, push away. So like when y'all like kindergarten, you like repel from this, okay? One of the most amazing things about magnets is the way they can attract other magnets or other magnetic materials at a distance, invisibly, through what we call a magnetic field. To ancient people, magnetism must have seemed like magic. Thousands of years down the line, we understand what happens inside magnetic materials, how their atomic structure causes them at we're more likely to define it as a force created by electric currents, themselves caused by moving electrons. So one of my favorite movies, I love all superhero movies, Avengers, all of that. Not so much like Batman. No, I didn't say it was. Okay. You know, Spider-Man, you know, Iron Man, that was like no, but when we think about the X-Men and Magneto, right, and some of the other superheroes or what are they called? The X-Men, right? The X-Men, they're mutants, right? Some of the mutants have the power to like bend metal. And so what the movie is actually trying to convey is that these individuals within their bodies possess a powerful magnetic field that allows them to draw metal to them, manipulate it, shape it, turn it. All of that has to deal with magnetism. So I can remember being your age and seeing a lot of these movies, and I would sit in my house, right? And I would like put a quarter on the counter and be like, what was I trying to do? I was like, for real, so like 20 minutes, be like, exactly, I was have to go to the toilet after. No, not, no. Maybe I should have put the penny on my head, I didn't think of that. But it didn't work because I don't possess a magnetic field. I don't have electricity going through me that would create a magnetic field. So let's see how that works. Suppose you put a bar magnet shaped like a rectangle, sometimes with the north and south poles in different colors, on a horseshoe magnet, then round into a U shape, onto a table, and place an iron nail nearby. If you push the magnet slowly toward the nail, there will come a point when the nail jerks across and sticks to the magnet. That's what we mean by describing. That's what we mean by magnets having an invisible magnetic field that extends all around them. Another way of describing this is to say that a magnet can act at a distance. It can cause a pushing or pulling force on other objects it isn't actually touching. So that would always like wow me in kindergarten. My teacher would bring in a magnet and she would put a metal something at the other end and slowly move it and then make it seem like she was calling with her powers. I thought she was a witch. She still might be. I don't know. Here we go. Let's read the 6 things we need to know about magnets. Number 1, Angel. We ain't talking about Santa. Okay. Number 2, Alvin. No. Very good. Number 3, Malik. Very good. Number 4, Jalen. The North Pole of a magnet points mostly towards Earth's North Pole and vice versa. That's because Earth itself contains magnetic material and behaves like a gigantic magnet. Now pause there. No one has ever been to the center of the Earth, but scientists believe that at the center we have a pure iron core. Iron, a metal, and they believe that it carries a magnetic field. Now, if I were to hold a compass in my hand, oh, that ain't where I'm going. I just realized that download the compass app. Anyway, I'm gonna do it and show you at the end of class. If I hold a compass in my hand, I can keep turning. The arrow will always point north to the actual North Pole because that is what the magnetic field of our Earth does. So if I literally took all of you, dropped you in the middle of the woods, and I said, our school is north from here, you would have to level your compass, turn it until you match up with the red arrow that points north, and you would literally just walk north. And that is how people stop themselves. I promise you. Go ahead. Exactly. It moves that needle because that needle is drawn to the magnetic field that is at the North Pole. All right, let's read number. What number are we on? 5 or 6? 5. Lamyra. Louder. Let me tell you what this does for. Anybody ever seen a centipede before? Yeah, that's not a cute little creature. Can't have. Have you ever tried to kill a centipede before? Okay. What happens if you hit it and you cut it in two? Yes, both ends. Now you got two centipedes instead of one. Okay? That's literally exactly what happens. It's terrifying. Okay, as a child, scarred for life. I'm saying, go. That's what you said. Kind of. The tail will become a lizard. You see how we're going? Yeah. But a centipede, right? Like if a shower was a centipede, and I took my shoe, hit her straight in the gut, her legs is gonna take off running. The top half is gonna take off running, and now it's two showers. That is not cool, right? But that's what happens to the magnet. If we were to saw a magnet in half, we would go from having one magnet that's north and south to now two magnets that have north and south and north and south. Number 6, Ramaya. Magnetization. All right, now we're going to apply the reading that we just took a look at. With your shoulder partner, I want you to answer questions 1, 2, and 3 on this page. You have 4 minutes. How long? 4 minutes. Now, complete sentences. Go back and use your text. I want you to annotate using your text. Ready, set, go. Already, so it's Travell. So just go back to it, annotate it, underline where you find your evidence. What does it mean? Opposite attract. What would I have to do to make this attract? Basically, these two magnets would not attract. What would I have to change? What would I have to change so that these two magnets attract? What end would this have to be? If there's a north side and a south side, this has to be what? North, because they have to be opposite. Okay? So when we say opposite attract, it means that the opposite ends of magnets are drawn together and they attract. Okay? You write the opposite ends of magnets attract. Love that focus. You're not talking to them. You didn't ask them one question. It says, how does the phrase opposites attract apply to how magnets work? Tracking, Jaylyn. Yes. Very good. Two opposite poles of a magnet always attract each other. Marmar, make sure we get this down. Awesome. Now it says, and I'll wait till I get it to a noise level 0. Awesome sauce. It says, using the text, explain how a magnet works. Each other. Explain how a magnet works. So no one has this down. That means we got to talk about it during lunch. All right. So I want someone to try. All right. Try it. Tracking Ramaya. Very good. So a magnet works by drawing other metals into its magnetic field. How? Is that electromagnetism? No, that's just magnetism. So if we have a magnet, what we're saying is, how does it work? It draws other metals to it. Okay? Now, Travell, based on what you just said, let's talk about electromagnetism. And that is, this picture is an example of it. So I said, take a look at the image to the right. Based on your observations, how does electromagnetism work? Imani, you'll go right after Ramaya. Jose? Hold on, pause it. Electromagnetic is beautiful. Electromagnetism works when any metal, you said it's powered by electricity. I'm going to tweak that just a little bit and say when any metal receives an electric current that runs through it, okay? Receives an electric current. And then once it receives that electric current, what happens? Go ahead, Jose. Very good. So again, I'm going to add one word to yours and say the metal then becomes magnetized. Magnetized and draws other metals towards it. Draws other metals towards it. Awesome. All right, we're going to bring all of this information together and talk more about how this works. The big piece that I want you to be able to answer once you are done with your brain pop skill is, how do I make an electromagnet stronger? How do I make an electromagnet stronger? So we're going to test that out next week when our circuits get delivered to see who can actually build the strongest electromagnet. There's different attachments that you can add to electromagnets. You can make a fan spin. You can make a car go. At the highest level, what I would like for us to do is actually build our own toy cars using electromagnets. And you'll be able to actually power the wheels using this type of energy. I'm so excited. Osman's going to paint her skin. Now, you have exactly 10 minutes to log into BrainPop, watch the electromagnets video, and answer the questions on the next page. Go. Okay, good. Did you draw the magnetic field? No. Oh, make sure that, so number 2 says label and draw your magnetic field. All computers are down in 5. It's a lunch intervention in 4, 3, thank you very much, 2, thank you, Marmar, 1, and 0. So what type of substances are magnets attracted to? Let's go over this quick. Shira. So I need someone who will answer in a complete sentence. Shankira. Okay, Malik. Very good. Magnets are attracted to metal substances. Close the door. Huh? What do you mean still? Steel, very good. to metal substances like steel and iron. Make sure voices are off. Thank you for those examples. How do we create a magnet using electricity? This is the big one. Tracking Dwayne. Very good. We can create a magnet by running an electric current. An electric current through a wire. Devin, make sure you get this down. But it has to be through a wire and around a what? A metal object, thank you. And around a metal object. So you've got to include both of those pieces in your answer or it's wrong. You have to mention that there is an electric current. However, the electric current has to be wrapped around a metal object. Otherwise, we're not creating a magnet. We're just creating electricity. Go, Imani. Number 5, what creates a stronger magnet using electricity? What creates a stronger magnet using electricity? Dwayne. Very good. Wrapping a coil around the metal object creates a stronger magnetic field. Thank you, Lamar, for getting these down. And then I just want you to draw a quick picture of that coil. Boom, 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 boom. So we know what we're talking about. How are electromagnets different from real magnets? Go ahead, tracking Angel. Woo, woo, woo. Hold on one. So electromagnets, I'm going to call those EM for short. So EM can be, and make sure voices are all the way off, can be turned on or off. Number 2, Angel. Very good. How do we reverse the polarity? Do you remember? What did it do? Yes. You turn the position of the battery. Is there a problem with your face? What is wrong with you? That just means we're excited to learn. It tells us thing and put it back in the shoe. Their polarity can be reversed. Give me the last thing that is different about these. Angel. Very good. Their strength can be controlled. We can increase the strength or we can. Very good. I see you, Dwayne. Hold on. So their strength can be, that was funny, controlled. So now let's take a look at the image model. I'm going to wait because I see a few folks are going to be added to my lunch directed list right now. I only have 3 from this class. I don't want any more. So it says, take a look at the image. I'm talking about this one. Which electromagnet is stronger? Which electromagnet is stronger? If I don't see your hand, you will be joining me for that lunchtime because I need participation. So it is either a college hand or it is a fist. I don't know what this is. Listen to the options. College hand or college hand with a fist. So tracking the way. How do you know number 1 is going to be stronger? Dwayne, I'm so glad you came back to life on me. Yes, the more coils you have wrapped around the metal object, the stronger it becomes. So we are going to write number 1 will be, and I'll zoom in. Excellent job, Dwayne. Number 1 will be the stronger the stronger electromagnet. And I'm still hearing conversation. Because there are more coils wrapped around the nail. So the more coils we have, the more electricity we have, the stronger the magnetization. Go. But that it's tighter because it has more coils. So you were kind of right. All right, ladies and gentlemen, last piece before we take our exit ticket. We're going to move to the independent practice. We're doing one closing text review. You are doing this silent and solo. You're going to read the 3 sections of the text. There are a total of 1, 2, 3, 4, 5 questions in the bottom box. You have 5 minutes to complete this before we go online and take our exit ticket. Yes, Travell. Yes, you may. After Malik, you'll be able to go. So computers are down right now, all the way down. Oh, you didn't go? I'm sorry. Who did I just say could go? Okay, thank you very much, Malik. Come on. I just forgot. I'm human. Chill. What? What thing? Oh. Electromagnetic induction. Shara, I saw you with a flawless answer for this. Tracking Ashara. Very good. Hold on 1 second. Go ahead. Very good. So the process of generating an electric current with a magnetic field. What is a current? And it's very simple. Go ahead, Jalen. Very good. A current is the flow of electrons. What measures the current? What measures the current? Go ahead, Lionel. Lionel, don't make it up. Bye, Lionel. Travell. You said what? An ammeter. Very good. Oh, that's what you said? Don't play with me, Lionel. An ammeter measures the current. What is an alternating current? Angel. Very good. An electric current that continues to reverse directions, okay? So when it's saying reversing directions, I just want to show you what that means very quickly. So do you see the magnet on the paper? Okay. So if the magnet is here, oh, snap. Okay. That's what it means by reversing directions. It keeps turning, it keeps going back and forth versus one singular motion. Okay? So again, we can power cars, we can power fans, we can power a lot of different things with electromagnets or magnetism. What do we use to power generators, John Kira? John Kira. To power generators. Not quite. That's a part of the process. But what is the primary source of energy to power it? Ramaya? Very good. So by making electricity, by moving a magnet inside a coil of wire. So for you looking at John Kerr, there are smaller generators that, yes, they run on fossil fuels. However, if this is our coil, the magnet continues to move, and that is what continues to power these electrons and give that generator energy. Right now, ladies and gentlemen, it is time for your exit ticket. Dwayne, let me sign it. Hold on. You're going to go to Illuminate. The name of your exit ticket is 6.psi.electromagnet. You have exactly 10 minutes to complete it. Go.